So this video, I'm going to show you how to conduct the chi-square goodness of fit test in Jamovi, and then future videos will talk about how to interpret and write those results. The chi-square goodness of fit, the purpose is when you have a categorical variable. So we're talking about one variable, and we want to compare the sample data, so the distribution across the different categories in that categorical variable. We want to compare it to either a hypothetical distribution, so what we would perhaps expect to find just based on a hypothetical, or we can use data on the actual population. So in this case, the research question is the proportion of first generation students in the sample different from the proportion of first generation students enrolled at Fresno State, which is 64.10%. And I got that data from our Office of Institutional Effectiveness. So for this one, I think it's important to think about what we're looking at. We're really comparing the observed frequencies, so the observed number of people in our sample in across those different categories of yes, first generation versus no first generation. We're looking at that compared to what we'd expect to find, and that expectation is from the hypothetical population or from data that we have about the population. So this test, you can use it a lot of different ways. I typically use it when I'm trying to compare demographic information about my sample compared to the population to see how well my sample matches proportions in the population. So I'm going to go ahead and pull this up in Jamovi. It's a pretty quick test, but there's a couple things that you just want to be really careful about. So here I am in Jamovi, and I'm going to go to frequencies, which looks like little cells, little boxes. And I'm going to go to N outcomes chi-square goodness of fit. So this is a one sample. So that tells you that we're just looking at one sample. We're looking at categorical variable, and we're going to use this goodness of fit test. So we're going to see how well our sample fits our expected proportions, which in this case is from population data. So the easy part is you just move your variable over. So first gen, I'm going to move that to variable. And you can see that it does not want you to move over. Jamovi tells you it has the little circles, or it has the little stepstones for ordinal variables. You're not supposed to use this test for continuous. That's not the right test. So this needs to be either categorical or nominal or ordinal. So it needs to have categories. Now, the tricky part is when you go to expected proportions, it defaults to an even number or an even proportion across each of the categories. So if I had 4 categories, the proportion would be 0.25 or 25%. Here we can see that we have 2 categories, and so it's split that into an equal proportion of 0.5 and 0.5, or 50% and 50%. So we just need to make this match what we're actually testing. So the percentage that I listed in the research question was that there are 64.1% first generation students. And so I'm going to turn that into a proportion. So 64.1 is 0.641. I just move my decimal points 2 to the left. So I get 0.641. And then I need my no to just be the remainder of the whole, which would be 1. So I'm going to subtract 0.641 from 1, and I get 0.359. Now, this is where, again, you need to be careful about this. I always look at this proportion column right here, and I see, does that match what I just typed in? Because it's really easy to make an error there. So you just want to double check that that's correct. Now, this will show this information here. The one last thing that I want to show is I like to do the expected counts because it tells us what we would expect to find if the proportions were the same in the sample and the population. So I'm going to stop here, and then in the next video, I'm going to talk about how to interpret this information. This is a non-parametric test, so it does not have the same assumptions that we have in a number of the other tests that we use. You're supposed to have a cell count of at least five expected in each category. And so if that were not the case, then you would have some difficulty interpreting this. You do also just want to think about how many people are in your sample. If it's really small, then you want to be careful about overgeneralizing, which is the case for any test. So I'm going to go ahead and end this video, and then in the next one, I will talk about interpreting the results.